This is my new module, which I've called Flip. It is a Bernoulli Gate designed to deliver similar functions to the Mutable Instruments branches module. Although unlike branches and its clones, this design has no software inside it because it runs entirely on hardware, unlike branches and its clones, which depend upon software running on microcontrollers. Flip accepts a clock input or a gate input from virtually any source into this input, which you see acknowledged on this green LED and duplicated on this output. And it's the purpose of a Bernoulli gate to route that input to one of two outputs, A or B. And the particular output that's chosen at any time is indicated by these red LEDs next to the outputs. And which output is chosen is selected by this probability control. When the probability control is in the middle, the decision as to which output should be chosen is pretty much like a coin toss. It's a fair decision and either output is equally likely. So you should see these lights flashing just about as regularly one as the other, although they're random. As you turn this main control further clockwise, the A output becomes increasingly likely to be chosen. I've just done that now. You increase the probability every time you advance this control clockwise until you get to a point where you can lock the device so it always goes to the A output. I didn't turn it quite far enough because it's still flashing. It's now locked. Similarly, if you turn it anti-clockwise, you get more and more likely to get outputs on B and less likely to get them on A until you get to a point around here where it's always on the B output. It's all very well looking at these things, but it's a lot easier if you hear the consequences. So let's choose two intentionally different sounds to represent the outputs. B, which I'll deliberately turn off while I connect it. B is going to be represented by this kick drum sound, or it's rather high, a drum sound at least. And A is going to be a pitched sound. Find the right piece of wire. Here we go. And you can hear Flip randomly selecting on each onset of the clock whether it triggers the periodic sound or the drum sound. If I advance the probability control clockwise, it moves to just the periodic sound. If I back off a bit, you'll hear mainly the periodic sound, occasional drum sounds. If I keep going, unlikely now to hear the periodic sound, and you can lock it out altogether and get just the drum sound. There is a second input and control through which I can apply a control voltage. This wire has currently got nothing, 0 volts on it. But if I apply 5 volts, it will change from this configuration where they're pretty much equally likely to be triggers routed to A or B, to a situation where it locks onto everything going to A. I'll just switch to them. I'll turn it off again back to 0 volts, and it goes back to where it was before. If I move the attenuverter control associated with that input to the other side of its travel, the same 5 volt input will lock it in the other direction to everything going to B. I'll make that switch now. And you see everything switched to B. And it'll go back again if I deselect that input. Instead of just applying manually switched 5-volt changes like that, I can put the pulse output from a low frequency oscillator, a bipolar signal in this case, into that control voltage input. And have the system switch periodically between output A and output B. So you see how the control voltage inputs work. It's all very well when that pitched signal on channel A is just at one pitch, but what happens if that were a sequence? Like that. If we then start to operate the Bernoulli Gate so that it only switches to this output A occasionally, what we're going to do is pick out notes randomly from that sequence. We can do it for most of the notes in the sequence, or for very few. And notice that you don't always have to use these complementary outputs, you can only use it to switch one signal. Again, very infrequently. Or almost continuously. Okay, a rather contrived demonstration gives you an idea of what Bernoulli gates are for in general and what flip does in particular. Unusually for me, I made the prototype for this device on Stripboard, and because of that I decided it was worth publishing a Stripboard layout for this project. The layout is included in the GitHub repository, which has all of the design files for this module. As you see, it's rather too big to run in a Eurorack format unless you mount it this way round, which would depend on having a deep rack. It's certainly not skiff friendly, shall we say. But if you're making for Cosmo or for Moog Unit or some other format, then this might be useful. Also, if you're just really wanting to experiment with the idea, this might be an interesting way of playing with the flip Bernoulli gate, a way which avoids the delay or expense or whatever of getting involved in the two printed circuit boards that lie behind the front panel here, necessary to build the flip module. All of those devices, components, the printed circuit boards and the front panel are fully described in the repository, a link to which I'll put at the bottom of this video, comments at the bottom of this video. And I'll play out with some more of that 6/8 time jam with which I started this video. Some of the random elements of which were generated by this flip module.